Good day. Thank you for taking the time to learn about a technology we're developing for hybrid packaging of cryogenic electronics and photonic technologies. I'm Mark Adams, founder and managing member of Systems Visions LLC, doing business as Civi. Today, I'd like to talk to you about magnetic shielding technologies for superconducting electronic applications. This is a topic out of the Office of Naval Research. Civi is a research and technology development company focused on photonic and electronic fabrication, packaging, and integration technologies. I founded Civi in 2007 with a focus on business-to-business services and solutions. We focus on design, fabrication, and testing of low-volume prototypes, and for this effort, we've licensed a patent for microfabricated magnetic shields from UCLA, and we have a patent pending for magnetic through-substrate vias in collaboration with our partners, UCLA and Auburn University. Civi is located in Auburn, Alabama, where I am also an associate professor of electrical and computer engineering at Auburn University. Our relationship with Auburn University allows us dedicated access to Auburn's Alabama Micro Nanoscience and Technology Center, 8,000 square foot clean room space, and microelectronics fabrication and testing infrastructure. We have a highly educated workforce with over 80% of our employees with either a PhD or master's degree. And due to our relationship with Auburn University, we have quick access to subject matter experts across the different STEM fields. At Civi, we offer many capabilities from the design and modeling of electronics and interconnect technologies to fabrication and testing of those technologies. We're developing microwave interconnect technologies for robust environments, from cryogenic electronics to high-temperature electronics. Our fabrication capabilities allow us to tackle unique challenges associated with the superconducting electronics industry. On this slide, you can see some examples of our microwave cable technologies that we're developing for the cryogenic industry. Why is the Navy interested in this technology? Well, electronic signal transfer from 4 Kelvin superconducting electronics to room temperature is lossy and typically requires a reduction in data rate. We hope to migrate to optical signal transfer from the 4K to the room temperature stage in order to minimize that signal loss and maximize the data rate. For superconducting electronic chips to function properly, the net magnetic field cannot exceed 4 microtesla. So a solution is required that can provide adequate magnetic shielding while also allowing coupling through optical fibers. That's the solution I'm presenting today. Today's capabilities just don't provide a path forward to meet the Navy's desires. There are 2 aspects of the current state-of-the-art that I'd like to discuss today. First of which are the shields. Magnetic shields typically don't support arbitrary shapes. They usually cover the entire assembly, and they're not suitable for fully integrated superconducting electronic and photonic systems. The other aspect is what's known as a superconducting multi-chip module. The superconducting multi-chip modules, or SMCMs, that MIT Lincoln Labs has developed do not include magnetic through-substrate vias. The vias are critical for maintaining shielding on a chip-by-chip basis. The Navy has worked with MIT Lincoln Labs over many years to develop this process. However, our studies have shown that we need to be able to include these MTSVs in order to achieve the shielding the Navy desires. Our solution is a hybrid integration of photonics and cryogenic electronics with magnetic shielding, or HIP-SIMs. HIP-SIMs is a customizable magnetic shielding system which includes microfabricated permalloy shields, magnetic through-substrate vias, and superconducting multi-chip modules with permalloy backing. It provides magnetic isolation at the superconducting electronics chip level and can be nested or extended to cover multiple chips. It's an enabling technology for high-speed superconducting electronic applications. It allows for tight tolerances and fabrication precisions, which allows for high-density chip-to-chip connectivity. So where are we currently in the development of the HIP-SIMs technology? We've recently wrapped up the first year of our STTR effort. We demonstrated a first-generation HIP-SIM shielding system in September of 2022. This included a single shield with magnetic through-substrate vias and a superconducting MCM over a single superconducting electronics chip. We evaluated this at 4K. We show that the shielding is effective. In our year 2 focus, we plan to enhance the performance and reliability of the shields, evaluate the shield scaling and nesting, and ramp up our internal manufacturing capabilities. Some of the key features, advantages, and benefits of the HIP-SIMS technology. Traditional shield forming techniques include stamping, welding, wire EDM, laser cutting, water jet, etc. Pretty much any standard machining technique can be used to generate a magnetic shield. They're formed out of a sheet of high permeability material, that's typically mu metal or permalloy. Unfortunately, the accuracies and tolerances are limited by the machining process. And in the best case, you're looking at 200 to 500 microinches. HIP-SIMS technology leverages advances in microelectronics fabrication to provide higher accuracy and greater material control. The tolerance or accuracy is limited by photolithography, in this case, typically less than 100 microinches. The shield composition is limited by what you can electroplate, permalloy, copper, nickel, any other material. And shield deposition is conformal, which allows arbitrary geometries which are almost impossible to form out of normal sheets and with standard machining techniques. HIP-SIMS is an enabling technology. It improves the performance of superconducting electronic systems. It is designed to work with existing integration technologies developed by the Navy and other government enterprises. This is why we've been working closely with MIT Lincoln Labs. We're looking for a transition advocate, someone who is willing to support the development of this moving forward. So where would the HIP-SIMS technology be applied? For the Department of Defense, it's going to be advanced radar, signal processing, sensing, and high-performance computing applications. In the commercial sector, we see high-performance computing and quantum computing benefiting from the HIP-SIMS technology. I think there'd be a large benefit to the superconducting-based quantum computing systems technology for HIP-SIMS. We're looking for partners and customers to transition the HIP-SIMS technology. Our commercialization approach is similar to most microelectronics fabrication. We would like to provide a process design kit, or PDK, to the customer that includes design rules on how to incorporate the HIP-SIMS technology into the customer's own designs. We will work with trusted facilities for the superconducting MCM design and fabrication, such as MIT Lincoln Labs. We've been collaborating with them for the last several years. We want to fabricate shields based on customer designs. The shields will be fabricated in-house, and we can provide full integration and test services for complete HIP-SIMS systems as needed. This would include full end-to-end packaging, integration, and test. In terms of the remaining steps, we need to complete our second year of the base STTR, hopefully find a transition partner, and further identify their needs and expectations. We want to continue to internalize fabrication and testing capabilities. And ideally, we would like to get the option for our STTR contract. Thank you for taking the time to listen to this presentation today. Please stop by our booth and visit with us to share your thoughts and discuss your needs. Once again, I'm Mark Adams, founder and managing member of Systems Visions, LLC. My contact information can be found on the slide below. Our company is located at 1500 Pumphrey Avenue in Auburn, Alabama. We're in the Auburn Center for Developing Industries complex. I look forward to seeing you at the booth, where I can share examples of our HIP-SIMS technology and provide additional performance details. Thank you for your time.